In this section we're talking about related rates. So first thing we have to do is understand what a rate actually is. So basically a rate is anything where you have a dt on the bottom, because that's going to be in terms of time. So you might have cubic meters per minute, that's a type of related rate, or miles per hour, something like that. So before we get into the actual word problems in this section, we're going to do some problems first, just practicing taking the derivative of both sides with respect to t. So we did that similar in implicit differentiation, but that was all in terms of dy dx. So now we're doing everything all by dv dt. So since we're doing everything in terms of t, anything that has a t in it in the formula, you would do your normal power rule derivative. However, everything else, all the other variables like x's and y's for instance, we're going to be using a chain rule, and then we'll end up getting these variables as a result, dx dt, dy dt. So let's jump into it now with this problem. We're given that v equals 2 times this quantity. We want to find dv dt by using implicit differentiation. That's what we're going to do first. So if I take the derivative of v with respect to time, I'm going to get dv dt. So on the left hand side of the equation I'll get dv dt. Now first let's just do this step before we jump into it. Let's multiply by 2. By doing that, we avoid having to worry about the product rule in that case. We're going to do the derivative. We get dv dt on the left hand side. Now these, we're going to apply the chain rule. So we're going to do the outside, bring the power down, and then we'll have to multiply by the derivative of the inside, and then when we do that, we're going to be getting these as a result, dx dt and dy dt. 2 comes down, we have 4x, and we're going to get dx dt. So again, I did the chain rule on the outside, that outside function did the derivative, multiplied by the derivative of the inside. We're doing that with respect to time, so we get a dx dt there. Then we get minus 6, and there won't be a y there, because normally I would just, using the power rule, this would be a power of 0, so that's gone, but we still have to put dy dt there on the end because we're doing the derivative of the inside. So this is the first thing they wanted us to do, find dv dt by using implicit differentiation. Now usually in these story problems they're going to give you some numbers that you can plug in and you can get a numerical answer. In this case they just tell you all 3 things to put in. So we want to find dv dt, but we're putting in a 3 for x. I have 4 times 3. dx dt is given as -1, so we'll put that in here. Minus 6, and then dy dt, they give us that dimension also. It's 4. So now I just have to work this out, and that's going to give me the exact answer numerically. So we're going to do dv dt. This is -12, and we have minus 24. So our answer is going to be -36. Do we have any units with this? No, not on this problem, because these other dimensions there's no units given, so it's okay to just leave our answer as a number. dv dt is -36. Here's another example that has the same type of instructions as the previous one. These are a little bit different instructions than what I had in the notes, but I kind of wanted to make these similar for you in case they ask this kind of question. For this one, they're asking us to solve for dy dt this time using implicit, and then we have these numbers that we're going to be putting in. Now we don't have a variable that's isolated here, so we're just going to do the same techniques we would do for implicit differentiation. This time we're doing everything with respect to time. So we're going to do chain rule on this. The 2 comes down, x, subtract 1, and you get x to the first power, but we have to multiply this by dx dt. We're doing the derivative with respect to time here. So normally when we did the other section, implicit differentiation, I would have just had 2x and that would have been it. That's because we were doing it everything with respect to x, the dy dx we were doing. But because we're doing this with respect to time, if there's no t in there, you can't just do normal derivative without this part here. You need to multiply by the derivative of the inside, and that's where the dx dt comes from. Let's do the next part. The 3 comes down. Subtract 1, we get 3y squared, and then times, this is dy dt here. On the right hand side you're going to have a 0, and it doesn't matter what you're taking the derivative with respect to, you're always going to get 0 there on that side because you're taking the derivative of a constant. Now, this particular question didn't ask us this in the notes, but this particular question is asking us first to solve for dy dt, so let's do that one. We're going to leave this on one side. We're going to move this one over to the right hand side. So 3y squared dy dt is going to equal negative 2x dx dt. So now we just need to divide both sides by 3y squared to solve for our dy dt. I'll put that here. So dy dt, when we divide, you're going to get negative 2x dx dt, all that divided by 3y squared. So if it did ask us to solve for dy dt, then here it is. There's our answer. But this one's asking us to find a numerical value, so we need to plug these numbers in now. So dy dt is going to equal negative 2 times 3, and then dx dt is 8. Down below I have 3, the y is 4. So I just need to divide this to get our answer. What you're going to get here is on top, this is negative 48. Down below is going to be positive 48. So when you divide all this, you're going to get negative 1 as your answer. And again, like the previous problem, we don't have any units here, so this would be your final answer, negative 1.